Hi, today we're going to do just a quick down and dirty overview of humans and pollution because it is a unifying theme throughout all of APES. We're going to touch on all of this again at some point during the year. So the first thing we need to do is define what is a pollutant and what's a pollution. Pollutants are released by human activities. So when we talk about pollution, we're talking about anthropogenic. We're talking about something that you or I have done that has negatively impacted the environment. Because in order for us to talk about pollution, we want to talk about the negative impacts. Obviously, no does science statement here. As human population has increased, so has the amount of pollution. So as our population gets bigger and bigger and bigger, our impact on the environment gets bigger and bigger and bigger. Pollution can come in three different forms. It can be in matter, and matter is a gas, a liquid, or a solid. Organic and inorganic, and think back to your chemistry days, the difference between something that's organic and inorganic. Organic contains carbon, inorganic doesn't. It can be energy. So as we sit here in my classroom recording this lecture, I can hear sound from the freeway construction. That sound, that energy that's coming across from the freeway is a source of pollution. I don't want to hear it. You don't want to hear it on the video. So we consider it pollution. Light can be a source of energy that's pollution. So when we talk about sea turtles coming in and making their nest on beaches, if there's a lot of light from the hotels that have built around those beaches, the sea turtles won't come in. They won't make their nests there. It can be heat. So when we give off heat, that's a pollution. When we've paved over a lot of our green spaces with asphalt and that asphalt then reflects the heat back out, that's a form of pollution. Living things can also be pollution. So they can be a pollutant. A living thing like an invasive species that comes in and carries disease is considered a pollutant. A biological agent that I spray is going to be a pollutant. And then we have two types of pollutants. We have primary and secondary. A primary pollutant is dangerous in the form that it is originally found in. So sound is a primary pollutant. If you're too close, it will blow out your eardrums. That's dangerous in the form that it originates in. Whereas a secondary pollutant has to mix with something in the atmosphere or mix with something in the water. There has to be a chemical reaction and then it becomes deadly. So when I put sulfur gas into the atmosphere and it mixes with the oxygen that's in the atmosphere, it becomes sulfur dioxide. It becomes hydrogen sulfide that rains down as acid rain. There's some chemical reaction that goes on. So primary pollutant, deadly in the form that it originally comes out of your tailpipe in, whereas a secondary pollutant, it has to mix with something in the environment. We can classify our pollution or our pollutants as combustion of fossil fuels, and those pollutants are carbon dioxide, sulfur dioxide, nitrogen oxides. These are all things that cause climate change and acid rain and respiratory irritation. When we have a bad air quality day, it's often because the stuff's in the atmosphere. That mixes and becomes a secondary pollutant and causes photochemical smog. And that's when you look out and the sky is kind of hazy. That's a secondary pollutant. Again, causes irritation to the eyes and to the lungs. It can actually start eroding at buildings. Carbon monoxide is a primary pollutant. Carbon monoxide, we see that a lot in the winter. People start dying of it because they're using heaters that are malfunctioning. They're releasing this gas into their homes. And carbon monoxide will bind onto your red blood cells in the same place as oxygen. And so if all of the carbon monoxide's on your red blood cells, oxygen can't bind there, and you essentially suffocate. So even though you're breathing, you're not transporting oxygen and you're suffocating within your own body. Domestic waste is any trash that's coming out of your house. So think about all of that stuff that you throw away. That's our domestic waste. We in our country take all of this to landfills and we bury it and make mountains or cemeteries. It goes underground if we're throwing it away properly. Other countries, it ends up in rivers and becomes a pollutant in that manner. Industrial waste is anything that's produced in the making or manufacturing of goods. A lot of times we're going to see heavy metals that are released as a byproduct of the manufacturing process, and that gets into the waterways. Fluorides, all of that causes poisoning. Heat is a byproduct here of manufacturing, and a lot of times these plants are built on rivers, and they're going to use the water from the river or the ocean to cool their machinery. And when that water goes back out, it's hotter than the surrounding water, and animals have ideal temperatures that they like to live in, marine organisms as well as things that aren't in the water, and they won't live in that superheated water. When we talk about sources of pollution, agriculture is a huge source of pollution. So when they're spraying pesticides on their fields, all of the fertilizer leads to eutrophication. Remember, eutrophication is an influx of fertilizer into a waterway. And as it goes into the waterway, the algae blooms, the algae dies, the bacteria decompose it, and then it uses all the oxygen and all the fish die. When we look at our pollutants, there's two ways to classify them. We can have point source and non-point source. Point source is the one that's the easiest, right? If it's a point source, we can figure out where it's coming from. And if we can figure out where it's coming from, we can stop it. When I got out of college, my first job was working for LA Sanitation. And there were these big, burly, like scary biker dudes that worked there as well. And their job was at night to go in, and we would have samples of like heavy metals coming into the sewer system, and they would actually go on stakeouts to find these companies that were dumping heavy metals into the sewer system. And they had to be like these big scary guys, because you know, if you're caught dumping stuff into the sewer system, you could be shut down for your company, you could go to jail, and these guys were dangerous, and so you had to have someone dangerous kind of doing the stakeouts. But it was point source. They could track it back to the actual company that was dumping this into the sewer system. And so it was easy then to stop that pollution from occurring. Non-point source, on the other hand, is a lot of dispersed pollution, and we can never quite figure out where it's coming from. This is like when we talk about the NOxes or the SOx, the gases that are in the atmosphere that are coming from cars. And yeah, we might say, man, the freeway by Mission Viejo High School, there's a lot of pollution, but we can never pinpoint it to a specific car. And because we can't pinpoint it to a specific car, we can't solve the problem. Often when we look at lakes and rivers, a lot of that pollution is going to be non-point source, that we are going to have a really hard time figuring out where that little bit of pollution is coming from. Persistent organic pollutants are something that's going to come up a lot during our course. A persistent organic pollutant is a pollutant that doesn't break down. So a lot of times, if you were to go out and spray your backyard for bugs, the next day that pollutant's gone. And that's why, like, you spray your backyard and kill all the ants, and then the next day there's ants again. It doesn't persist. It doesn't last in its form. It breaks down into inert stuff that's not going to be deadly. A lot of times you could spray and it lasts for a month and then it breaks down. A persistent organic pollutant doesn't break down, and DDT was a prime example of a persistent organic pollutant. Once it went out in the atmosphere, it stayed out in the atmosphere, it stayed in the environment, and it caused problems for a long period of time. And remember DDT we talked about in our disasters? DDT is the one that was weakening the shells of our predatory birds, and then mama bird would sit and squish baby bird. So we don't want persistent organic pollutants. We developed them because at the time we wanted to kill things and we didn't want to have to keep spraying pollutants and pesticides on the environment. We just found out that the pesticides we're spraying aren't just killing the pests, they're killing a lot of things. There's a couple videos on here, and again, like I say, every lecture you guys need to go in and watch these videos because it does explain these issues in greater detail with firsthand accounts, and that's easier to understand than, you know, me sitting here on a Zoom lecture. But DDT, the good thing on DDT, remember, just a refresher because DDT comes up a lot, is that it was used to kill mosquitoes, and mosquitoes carry malaria, and a good portion of our world has malaria. It's the #1 killer still. But the side effects of it is, for example, DDT then accumulated in geckos, and the rats would eat the geckos and it would accumulate in the rats, and then the cats would eat the rats and the cats would die. The other one is there was a parasitic wasp that controlled the caterpillar population. You get rid of the parasitic wasps, and now the caterpillars overpopulate. Well, the caterpillars actually were eating the roofs off the huts that were like the grass roots. And so now you had people that didn't have homes anymore. So DDT, while it was doing something really good, was also doing a lot of things that weren't really good. Okay, back to types of pollution. We have acute and chronic. Acute is, oops, my tanker ran aground and I'm spilling oil, and it's a one-time thing and I can clean up that one-time thing. Chronic is like our air pollution coming out of our tailpipes of our cars. It's a little bit over a long period of time, and for a long time it goes undetected until it accumulates. And because it's chronic and it's a little bit over a long period of time, it's hard to detect the source. And if we don't know the source, again, it's hard to clean it out. When we talk about the detection and monitoring of pollution, we're going to either do a direct measurement or an indirect measurement. A direct measurement is I literally go out with my tools and I measure what's going on. So if we talk about acid rain, I collect some rainwater and I dip a pH strip in and I know what the pH is. I can go out with meters and figure out how much carbon dioxide is in the atmosphere. I can figure out how much lead is in the paint that my kid's chewing on. An indirect measurement is just what it sounds like. I'm not looking for the pollutant itself, but I'm looking for the side effects of the pollutant. When we look at frogs, they are a huge indicator species that tells us there's an indirect measurement of pollution. If the frogs start seeing like defects and extra limbs, or they start dying, it's telling us there's something wrong in the environment. It's not going to tell us exactly what's wrong in the environment, but it tells us there's something wrong in the environment. One of the things that we're going to do later in the year, hopefully, is the Trent Biotic Index. This is an indirect measurement of pollution where we go and we sample the organisms found in a body of water. And we know there are certain organisms that like really clean water and certain organisms that do really well in polluted water. So based on what we find, the clean water organisms or the dirty water organisms, we have an indirect measurement of the health of that body of water. So then how do we measure and manage pollution? If we know there's pollution, whether it be acute or chronic, whether it be point source or non-point source, how are we going to deal with it? Because when we talk about environmental science, it's one thing to identify the problems, but what we really want to do is come up with solutions. The first thing we're going to want to do is alter the human activity that's causing pollution. So when we identified that straws were an issue, we then started having social norms where a plastic straw is kind of frowned upon. So we do that through education, we do it through campaigns, we do it through social pressure. We can look at controlling the source of the pollution through legislation by saying, look, we'll let you have pollution because we know you can't manufacture without it, but we're going to limit how much pollution you're allowed in a given year. And that's going to encourage you to get better technology so that you don't pollute as much. We're going to legislate it and say, if you go over that amount, there's going to be fines, there's going to be jail time, there's going to be some repercussion for what you're doing. And then we're going to go in as grassroots organizations or as a Superfund site, and we're going to clean up that source of pollution, and we're going to try and restore the environment to what it was before the pollution occurred. Again, please go in and watch these videos. They're really important for your understanding, but that's just a quick down and dirty, 15-minute look at pollution. And again, all of these topics we're going to hit upon the entire year.